References in C++. When a variable is declared as reference, it becomes an alternative name for an existing variable. A variable can be declared as reference by putting an ampersand in the declaration. Following points must be noted while handling reference operators. A reference should always be initialized. Reference cannot refer to constant literals, and it can only refer to variables. Once a reference is created, it cannot be later made to reference another object. So because of these limitations, references in C++ cannot be used for implementing data structures like trees, linked lists, etc. But references are, yes, safer and easier to use. Let's write a program and understand reference variables. So include your header, using namespace std and your main function. Now say I have a variable a. Let me initialize with value 10. So I have used an integer a initialized with 10. Now I'm going to create an alias or reference to my variable a. So how do you create? Since a is integer, the reference variable should also be of integer type. Use the operator AND. Specify your reference variable name. Let me use it as b. Initialize it with a. Now this statement says that the reference variable b is referring to a, or you can say that b is an alias to a, or b is an alternative to a. Now how do you verify this? Let's print the value of a as well as the value of b. So the content of a is pretty clear, it is 10. So what will be the b holding? So since b is an alternative or an alias to a, b should also have the same value as that of a. Let's verify this. So include your return statement. Yes. You can see your output here, a equal to 10, b equal to 10. That means b is a reference to a. Now, whatever changes you make to a will be reflected on b and vice versa. Let's check. Suppose I am incrementing the value of a. So I have not touched b. But since b is an alias or reference to a, the changes on a should be reflected on b as well. Let's verify. I'm using the same statement. So let me copy paste it. So what is the expected output for this? A I'm incrementing. So a should get me 11. Since b is a reference to a, it should also give me the same value as 11. Let's verify. Yes, the first output is a equal to 10, b equal to 10 from this statement, initialized. The second is the incremented value. So the incremented value is reflected onto b as well. So a equal to 11, b equal to 11. Same way we will proceed. We will make change to b and then let's see whether it is getting reflected onto a. So build and run. this, you can see the output remains the same here. A equal to 11, B equal to 11. So reference variables are nothing but an alias to an already existing variable. Whatever changes you make either to the reference or to the existing variable, it will be reflected on both. So though references has few limitations compared to pointers, it is easier to use. That is, your references don't need dereferencing operator to access the value, and they can be used like normal variables.